definition is same, but the only difference being it rolls inside a circle. All right, fixed circle is directing and the rolling circle is moving. All right, so let's do this. So this is capital D with this as the radius. We're going to have a circle, that's it, and inside which we're going to make a rolling circle, something like this. So that's the rolling circle. Now let's say this rolling circle wants to start from this position and end up somewhere here, having a revolution, one revolution in fact. In that case, it's going to be revolving in an anti-clockwise sense. All right, something like this. Let me show you how. Anti-clockwise. So this is the point P upon which we need to keep a track on, and as we move forward, you're going to see that this point P is moving in a certain direction, something like this. Please keep on watching. That's it. Anti-clockwise sense, we keep on moving, and here we have the final point. All right, now let us join all these points in sequence. We're going to have what you call a hypocycloid. Again, the angle subtended over here is going to be, the formula for that angle is going to be same as we saw in the case of epicycloid. So that's exactly what you call a hypocycloid. All right, guys. So this is the portion which you need to make. That's it. So guys, that was all from my side. If you have any doubts or queries, do write them down in the comment section below. I'll be very happy to answer them as quickly as possible. And guys, if you believe that this video has added value to your knowledge of engineering drawing, then do recommend this channel to your friends and classmates so that all of you can learn engineering drawing in the best possible way. So this is Manas Patnaik signing off. Take care, have a great day, and keep drawing.
Day 108.
रात लंबी सही, पर करने से ही होगी सुबह नहीं.
But what the hell is a cycloidal curve? Well, these curves are generated by a fixed point on the circumference of the circle. Circle may be called cycloidal curves. So let's see all of these curves generated by a point P on the circumference of a circle. So there is a point P on the circumference of a circle which moves along the straight line, all right, without slipping. Now this particular circle is rolling along a straight line without slipping, and we need to keep a track of a certain point. So let's say we have a point over here, this red point you see, all right, and this is the circle having a diameter d, rolling in the clockwise sense. And suppose this circle completes one revolution, the horizontal distance it's going to travel will be equal to the circumference, that is going to be pi d. Fine. So let's move ahead and let's see where this point goes. We're going to keep a track of this point, all right, and after having tracked this point, we're going to join all those points with the help of a smooth curve. So let's see how it goes. Fine. So let's say the circle has moved forward, and this point will now arrive here. Let's give one more rotation. It comes over here, and the circle keeps on rolling. The points moves further right hand side and also to the top, something like this. Please keep a watch. All right, that's it. Now you observe initially for the first half revolution, this point was moving towards the right as well as it gained height. Okay, but for the next half revolution, it gained horizontal distance but it lost height. Fine. And this is what you call the track points, and when you join all these points with the help of a smooth curve, you're going to have a curve that in fact is going to be called a cycloid. Okay, I'm going to show you what it is. So this is what you call a cycloid. Fine, guys. So this was the circle rolling along a straight line. Now this circle in fact is also this rolling circle. There is also one more name to this. We can also call this as a generating circle. In some of the books you'll find that this is called as a rolling circle. In some books you'll find it as a generating circle, so not to be worried about. And this horizontal line is also referred to as a directing line. Now let's move forward, and now let's deal with what you call an epicycloid. Fine, let's have the definition. Well, this is the curve generated by a point P, again on the circumference of a circle, which rolls outside a circle. Now there are two circles in this particular case. One is the circle which is rolling, and the other one, that is the directing circle, which is fixed. Okay, so let's start and let's have a circle. This one is what you call the directing circle, above which we're going to have a rolling circle. Okay, let me show you how it is. So this is directing circle is having a diameter t, and somewhere here we're going to have a rolling circle, something like this. Please watch carefully. This is going to have a diameter small d. Okay, so this is the rolling circle. Fine, let's move ahead. Let's say that this rolling circle is rolling in the clockwise sense. Fine, something like this. Let's start from this point. So this is the point P on the circumference. On this circumference, we have this point P. Rolls down, this point P reaches here. Fine. This process goes on, this point P comes here. Goes on, it will come over here. And let's move forward at the apex. Now it will start to come down. Okay, so this is for the first half revolution. Fine. Let's keep it going, keep it going, keep it going. And finally, when one revolution is complete, then this point, this is the start, this is the end, and that's what you call an epicycloid. Fine, rolling in the clockwise sense, but outside the given circle, also known as the directing circle. One more thing that you guys must realize that we started from this point and we ended over here. And there is some kind of an angle which has been subtended at the center of the directing circle. Fine. And this angle can also be computed with a simple formula, 360 multiplied by small d over capital D, or small r over capital R. So this is how you can actually find the angle subtended at the center of the directing circle for one revolution of the rolling or generating circle. So this, guys, was all about epicycloid. Remember, epicycloid rolling circle is rolling outside the directing circle in the clockwise sense. As far as drawing is concerned, you're going to have to make only this portion. Okay, so this much portion has to be eliminated, something like this. All right, so whenever you're making an epicycloid, you need to make only this portion. That's it. Now let's move towards hypocycloid.